Yes. Let me start. So as I said before, going to start the double integration or multivariable calculus, let us understand integration first. There are many students who did not study integration at all. So let us try to understand integration. So yesterday I had given some problems, formulas as well, and some of the small problems we have done. Now I will write the formulas again, which I'm going to use to solve the problem. First one, the formula. Yesterday I have given x to the power n dx is equal to x to the power n plus 1 divided by n plus 1 plus c. This is the first formula. Second one, integration of e to the power ax dx is equal to e to the power ax divided by a dx. Look at this formula. If you have only e to the power x, the answer is only e to the power x. If you have any coefficient of x, then we have to divide. Okay, then we have to divide. I have written it is wrongly. It is plus c. Okay, we have to divide. So whatever the coefficient is there here, we have to divide that. For example, e to the power 3x, e to the power 3x by 3, e to the power 4x, so e to the power 4x by 4. This is the second formula. And the third one, integration of, yesterday I had given the formula for sine x, sine ax. So integration of sine ax is minus cos ax divided by a plus c. So whatever the coefficient is there x, that we have to divide. Okay. The fourth one, integration of cos ax dx. This is equal to sine ax by a plus c. Okay. So these are the formulas. Now we'll try to see the problems on these formulas. And one more, let me write the formula. We are going to use this also. If you have two function u into v, if you have two function, one is u, one is v. See, in these all the formulas, we have only one function, x to the power n, e to the power x, sine x, cos x. If we have two function of x, any two functions of x, this is f of x and this is g of x, then we use by parts or Bernoulli's by parts integration, which says keep u as it is, integrate v, minus differentiate u 2 times integrate v, plus again differentiate, double differentiate u and 3 times integrate v, minus so on. So it will go on until you get differentiation of this term as 0. I'll repeat, keep u as it is, integrate v, minus differentiate u and double integrate v, double differentiate u, triple integration v, minus so on until this u term. You need to choose a u term such that after some differentiation, after doing the differentiation after after doing second, third or fourth differentiation of u term, it should be 0. Okay, we'll see the examples of that. No need to worry about. Okay. Now shall we'll see the example. I hope all of you got these formulas 1, 2, 3, 4 and 5. Right now these formulas are enough. First example. You have already know this answer, x cube dx. What is the answer? It is x to the power 4 by 4 plus c. Okay. Second one. What is the answer for e to the power 5x dx? What is the answer for e to the power 5x dx? What is the answer for e to the power 5x dx? Integration of e to the 5x is e to the power 5x as it is, divided by 5 plus c. Yes, Rahul, Tushar, it is correct. Okay, and the third example, integration of sine of 4x dx. Okay, all of you write the answer for this. Integration of sine 4x. Integration of sine 4x. All of you write the answer for this. Sine to the power 4x dx. What is the answer for sine 4x dx? It is, anybody? Minus cos 4x divided by 4 plus c. Remember, sine will become minus cos, and cos 4x divided by 4. Whatever the coefficient is there, we have to multiply. Fourth one, integration of cos 5x dx is equal to. Yes, correct answer, all of you. What about cos 5x? What is the answer for cos 5x? Cos 5x. Correct answer. It is sine 5x. Cos becomes sine. And whatever the coefficient is, that we have to divide plus c. Plus c. I hope all of you understood. So we have applied 1, 2nd, 3rd and 4th formula very easily. And remember, if there is any constant is multiplied to these functions, you have to keep those constant as it is. For example, if you have fifth one as integration of 24 sine 6x dx, what you will write the answer? 24 sine 6x dx. 24 is a constant term. 24 is a constant term. So you keep 24 as it is. And then you integrate sine 6x. Sine 6x is minus cos 6x divided by 6 plus c. Then you can simplify. So what will be your answer once you simplify? 6 4 za. So minus 4 cos 6x plus c. Okay, this will be your answer. Remember, again I'm telling you, if it is a single function, then you know the integration, we can apply directly the formula. If any constant is multiplied, constant may be any number or a, b, c, d, anything, you have to keep it as it is. Constant can be any number or any variable like a, b, c, d. So those constant kept as it is. Then if you want, you can simplify. But instead of a constant, if there is any other function, then we have to go for the fifth formula. I will give you the example. Before that, you can write the answer for this. Integration of 100 e to the power 50x dx. Okay, all of you write the answer for this. Direct answer I want. What is the answer? 100 e to the power 50x dx. It is 100, okay, not 160. Yes, exactly correct. 100 e to the power 50x divided by 50. If you simplify, you get the answer as 2 e to the power 50x plus c. Very good. Now we'll see the next stage of these. Now, what if we have integration of x square e to the power. Okay, let me remove that. E to the integration of integration of x cos x dx. X cos x dx. Now look at this problem properly. Cos x is a function. X is also a function. If it is a constant, we have to keep it as it is. But it is not a constant now. It is not a constant. So what we have to do? This is, you need to take it as u, and this is, we have to take it as v. Why we have to take this as u? Why we have to take this as v? When you differentiate cos x, you get sin x. Again, if you differentiate sin x, you get cos x. Again, if you differentiate cos x, means it won't get eliminated after certain times of differentiation. But x differentiation is 1. 1 differentiation is 0. So after certain differentiation, x is getting eliminated. So we have to take x as u and this as v. I hope all of you understood. Yes or no? How to identify u and v? It is multiplication of two functions. X is a different function. Cos x is a different function. When there are two different functions, we have to go for fifth formula, and you need to identify which is u and which is v. Okay. Now go on applying this formula now. What it says, what this formula says now, keep u as it is. Keep u as it is, that is x as it is. Integrate cos x. Okay, you can directly integrate, but let me write one step. Minus differentiation of x. What is the differentiation of x? That is 1. Double integrate cos x. Again, differentiate this 1. It will be 0. So that's it. Now your answer will be x. Cos x is sin x minus 1 will be, and double integration of cos x means what? You need to integrate sin x. What is the integration of sin x? Minus cos x. So the answer is x sin x plus cos x. X sin x cos x. Otherwise, I could explain like this. If you did not understand that, keep u as it is, and integration of cos x is sin x. Integration of cos x is sin x minus differentiation of x is 1. See, double differentiation of x is 1. Double integration means integrate the previous term. Previous term integration is cos x. So answer is x sin x plus cos x. I hope all of you understood. I will give one more example. You try this example. 8th one. X sin x dx. X sin x dx. Directly write. This is u and this is v. Keep u as it is. Integrate x sin x. Yeah. Now you can unmute yourself if you want to speak, but not at a time, everyone. Yes, Fahim. I'll repeat number 7. See, keep x as it is. X kept as it is. Integration of cos x is sin x. Okay. After this, you need to continue. Minus differentiation of this. Integration of sin x. Integration of sin x. Okay. I hope all of you got the answer. Let me change it as, I know that you might got. Yes.
So can you hear me, sir?
Yes, I can hear you.
Sir, I'm saying something about the fifth formula, UV.
Yes.
I think there is another way to solve it. That is U integration of V dx plus V integration of U dx. Is it right?
That is by-parts formula. I know that formula, but I am giving you the Bernoulli's by-parts formula, which will be easier than the by-parts formula what you have studied. Okay.
Okay. In your previous classes in 12 or 11th grade, we learned that.
Yeah,
That's
I
why.
know, I know it, but I am teaching you which is necessary for now.
Okay, sir.
Okay. So no
Okay,
need to
sir.
get confused and confuse others. So this is the formula what we have to use now. Okay.
Okay. Okay. Thank you,
Because
sir.
we are going to get the terms in this form. So this formula is enough. If
Okay, sir.
ever required that formula, I will tell everybody. Okay.
Okay, sir.
I will teach that also.
Thank you, sir.
Now I have changed here terms x square sine x. Now x square sine x, how do we have to solve? Keep x square. This is u and this is v. Keep x square as it is. Sine x is minus cos x minus differentiate the previous x square. It is 2x and integrate the previous term. What is cos x? It is sine x. Minus will be as it is. Plus differentiate the previous term. Differentiation of 2x is x is 1. So it is 2. Again, integration of sine x is minus cos x. So it is cos x. Okay. All of you check this again. Check this. Keep u as it is. Integrate sine x. That will be minus cos x. Differentiate x square. You get 2x. Integrate cos x. You get minus sine x. Plus differentiate the previous term 2x. It is 2. And integrate the previous term. So you have to go on integrate and differentiate and integrate the previous terms. You have to go on integrate and differentiate the previous terms. All of you got the same answer? Yes or no? Okay. Now, I hope you have written it. I will clear the screen and I will start one more slide. I'll clear all drawings. Okay. All of you solve this one. E to the power, e to the power 2x x cube dx. Now, can anybody tell me which is u and which is v? Which is u?
Sir, u is e to the power 2x and v is x cube.
No. No.
So it's the other way around, because when we differentiate e to the power x, it won't be differentiated, it won't be cleared out, but x
Yes.
power 3 can be cleared out.
Yes, because when you differentiate e to the power x, how many times 100 times you differentiate, e to the power 2x remains as it is. But x cube, if you go on differentiate, it will get eliminated at certain point. That's why we have to take u as
x cube is equal to u.
Yes, this is u and this is v. See, don't go on the order of whatever the question is given. You need to identify u properly. I hope all of you got my point now.
Sir, eyelet rule is applicable, na? Eyelet rule.
Yes, eyelet rule. That's what the eyelet rule is. Now, what it says, keep u as it is. Integrate e to the power 2x. What is integration of e to the power 2x? E to the power 2x
E to the power 2x, sir.
by 2. Correct? Next, minus sign. See, these are the alternative sign. Plus, minus, it will go. Differentiate the previous term. 3x square.
3x square.
Yeah. And again integrate this term. E to the power 2x is e to the power 2x divided by 2. Already we have 2. It is again 2. I hope all of you got this point. E to the power 2x differentiation is e to the power 2x divided by 2. One more 2 we have already. Plus again differentiate the previous term. 3x square differentiation is 6x. Again integrate e to the power 2x. 2x. 2 into 2 into 2. Minus differentiate x. Differentiation of x is 1. So it is 6. E to the power 2x divided by 2 into 2 into 2 into 2. Again, if you differentiate 6, it is 0. That's it. It is very simple procedure to apply this Bernoulli's by parts integration. Keep u as it is, integrate the v term, differentiate the u term, integrate the previous term, differentiate the previous term, integrate the previous term, differentiate the previous term, integrate the previous term. That's it. So your answer will be x cube e to the power 2x by 2 minus 3x square e to the power 2x by 4 plus 6x e to the power 2x divided by 2 to the 4, 4 to the 8 minus 6 e to the power 2x divided by 2 to the 4, 4 to the 8, 8 to the 16. Further, if you want, you can simplify. Further, if you want, you can simplify. Okay. So I hope you understood the by parts integration, Bernoulli's by parts integration, and some of the integration problems. Now I would like to go for double integration. For him, you raised your hand. Any doubts? Any particular doubts by Fahim? Okay. So whatever we did till now is a definite integral. Means there is no limit at all. It is a definite integral. Now we'll see indefinite integrals. Okay. Indefinite integral says, okay, if integration of a to b f of x dx, means if there is any function f of x and limits are from a to b, then we have to integrate this f of x. We have to integrate this f of x, and then we need to substitute these two limit. Okay. For example, integration of f of x is capital F of x, for example, and limits a to b. Integration of f of x is capital F of, because we don't know what the function is. We assume that integration of f of x, we are getting it as capital F of x. Then we have to substitute b into place of x. So f of b minus, in place of x, we need to substitute a, f of a. This is the answer. Yes, plus and negative sign are randomly, one by alternatively you have to use in the Bernoulli's. Plus, minus, so on. Okay. I hope all of you understood. If there are limits a to b, f of x dx, you integrate the function first. Then write the limit as a to b. First apply the upper limit in place of x, so we get f of b. Then apply the lower limit in terms of x. Then we get f of a. Okay, let us see the example now. Example. Integration of 0 to 1 e to the power x dx. E to the power x dx. First integrate. E to the power x integration is e to the power x. Limits are 0 to 1. Now in place of x, you need to substitute 1. So e to the power 1 minus, because we have to write minus. In place of x, substitute 0. So e to the power 0 is equal to, answer is e to the power 1 is e to the power 0 is 1. This is the answer. And we don't write plus c. When we get limits for the integration, we don't write plus c. These are definite integral. Done? All of you, any doubt, please ask. If you have any doubt in this, please ask. No doubts?
No.
Okay.
No, sir.
Yes.
No,
Good.
sir.
Yes. Good. Second example. Integration of 0 to 1 x cube dx. I want you to solve. X cube dx.
So answer is 1.
Okay. Now integration, you do it first. Integration will be x to the power 4 by 4. Limits are 0 to 1. Correct? And remember, in place of x, we need to substitute 1. In place of 0, in place of x, we need to substitute 0. So it is 1 by 4 minus 0 by 4. In place of x, if you substitute 1, you get 1 by 4. In place of x, if you substitute 0, you will get 0 by 4. So what is the answer, guys?
1 by 4.
1
Yes,
by 4.
yes, it is 1 by 4. So I hope you understood this problem as well.
Yes, sir.
Good. Now third one. Integration of 0 to 1 sine 2x dx and integration of 0 to 1 cos 4x dx. I want you to solve. I want you to solve these two.
So I think the result is sine 2.
What happened? See, whatever the answer we get, it doesn't matter. I want you to substitute. I want you to know how to substitute. Okay. Sine 2x is minus cos 2x divided by 2. Correct?
Yes.
0 to 1. Keep this. See, sometime what happens here, we took this constant also and we substitute. But sometime what we can do, whatever the constants are there, we can keep it outside. What are the constants we have? Minus 1 by 2. So do one thing, keep this minus 1 by 2 outside. And what is remaining? Cos 2x. Here I have to substitute 0 and 1. So minus 1 by 2 as it is. Cos, if I substitute in place of x is 1, it is cos 2 minus. What is cos 0? What is cos 0?
1.
Yes, remember?
1.
Here it is cos 2 into 0, so it is cos 0. I'll write here, since cos 0 is 1. This is the answer we get. Similarly, here if you solve cos 4x, integration is sine 4x divided by 4, 0 to 1 is equal to 1 by 4 is a constant outside. Keep sine 4x, 0 to 1 is equal to 1 by 4, keep it outside. And sine 4x is sine 4. If you substitute in place of x1, it is sine 4. Minus, what is sine 0?
0.
Sine 0 is equal to 0.
0.
Yes. So answer is sine 4 by 4. So these are definite integrals. So now we studied indefinite integrals, Bernoulli's by parts integration, and definite integrals as well.
Sir, I didn't clear about the definite and indefinite integral.
No. If there is any limit, it is definite. See, 0 to 1. Here there is any limit?
Indefinite.
There is no limit, right?
Yes.
Indefinite integrals. Understood?
Thank you, sir.
Yeah.
Yes.
No, don't do anything here. Abid Singh, just these are example to understand how to substitute the limits. Don't do anything here. Okay.
Okay, sir.
Yeah.
Okay, sir.
So we'll go for double integration now. I'll clear. Now, first example. Solve double integration of xy dx dy. Hope we have solved it yesterday, but I want you to solve it again. So what it says, we need to double integrate. Here we have dx and dy, means two variables. We have two variables. First, with respect to what? We have to integrate this first with respect to which one?
X.
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 This is with respect to one, then second. Remember,
Y.
if there is dx first with respect to x, we have to integrate. If there is dy first, second, then second dy. If it is in the first place, then we have to do it with respect to y. Now, and remember, whenever you integrate with respect to x, y is a constant. Okay. Now, what will be the answer we get? One integration gone, one integration is remaining. We are doing with respect to x. So what is the integration of x? X square by 2. Keep y as it is, dy. So this is gone, and this integration, this dx is gone. Understood? We kept y dy as it is. X dx we integrated. I'll repeat. X dx we integrated, y dy we kept as it is. Now, again, we have to integrate with respect to y. Treat this x square by 2 as a constant. Constant means if it is, there is any 24, what you have to do? Keep it as it is, right? So here x square by 2, keep it as it is. And integration of y is y square by 2 plus c. Done. This is the answer. All of you understood?
Sir, I thought that first we have to integrate. First we have to keep constant the x, and then we have to constant.
Now see, in this you get the same answer, but follow the procedure, because later on what we do, we have to follow the same thing. Okay. Here, whatever the first term is there, you have to integrate with x, then with respect to y. Integrate with respect to x first, then with respect to y. Follow this same procedure. I will tell you later why it is.
Okay.
First, we have x, y, dx, dy. So we integrate with respect to x first, keeping y as a constant. So we kept y as a constant. X integration is x square by 2 and dy. Then dy is there. We have to integrate y with respect to dy, keeping x square by 2 is a constant. So integration of y is y square by 2. Understood?
Yes, sir.
Yeah. See the next example, because it is not that you will understand in one example. You have to practice it. Yes. Now you try. All of you please try. First we have dx, then we have dy. So when you do with respect to x, treat all the terms, all other terms as a constant. Only concentrate on x. Keep all the term as it is. After that, do it with respect to y and keep all other terms as it is. Got the answer?
2x cube by 3 y cube by 2 plus c.
Into y cube by 3 plus
Yes. So first thing, one integration is gone. 2x cube by 3 into y square dy. See, I kept 2 as it is. I kept y square as it is. I kept dy as it is. Only I touched x square. So it will be x cube by 3. Okay. Now I have to do with respect to dy. So I will touch only y square. Remaining term, this 2 or x cube by 3 as it is. Y square integration is y cube by 3 plus c. I hope all of you got the same answer.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now I will change a little bit in this problem. Double integration of x plus y dy dx. Okay. Solve. Remember, whenever you integrate with respect to x, you treat other variable as a constant. And we have studied that integration of constant is x if you are doing with respect to x. Integration of constant is y if you are doing with respect to y. And you have to do with respect to y first, then with respect to x. Got the answer?
Yes, sir. X square y by 2 plus y square x by 2 plus c.
Yes, correct.
X squared plus y squared by 2 plus c.
Let's see now. Let's see what is the answer. We have to do with respect to y first. We have to do with respect to y first. So what you will do with x? X is a constant, right?
Yeah, it becomes 0.
No, in integration, a constant is not 0. In integration, the constant will be x if you're doing with respect to x. And if you're doing with respect to y, it is y. For example, what is the answer for phi dy? Integration of phi dy.
5y.
Phi y, correct? Similarly, x is a constant.
Okay.
So what you will write?
X squared.
Xy. X is a constant when you are doing with respect to y. So when phi dy is phi y, x dy will be xy.
Y.
Understood?
Yeah, sir.
Xy plus y is a variable, so it is y square by 2. So integration remains dx.
Shit.
I hope all of you understood the first step. When you are doing with respect to y, x is a constant and there is an addition between these two. If there is a multiplication, you have to keep it as it is. If these are two different terms, then x, when it is a constant, you have to multiply y. So what you are multiplying to this? Y. Now again, you are integrating with respect to what? X. So here, there is a multiplication. So keep y as it is. Integration of x is x square by 2y plus y square by 2 is a constant. So when there is a constant separately, independent term, you have to multiply x. How many of you understood?
So when we change the order, let's say we have to differentiate to what's this?
Change the order means what you are asking? dy dx, huh?
Yeah, when we swap them, does it affect the answer?
No, here it doesn't affect actually, but the limits, when they give the variable as a limit, then it will change, affect the answer. Okay. Now it doesn't matter. It won't change. You can do dx dy or dy dx. You can do it.
Okay, sir.
Yes. Okay. Done. See, I'll explain the third example again. See, I will tell you the first example first. Once again, I will repeat the first example. When there is x and y, it is multiplied. These are a same term. They are multiplied. When they are multiplied, when you are doing with respect to x, other term should be kept as it is. It is a constant and kept as it is when they are multiplication. But if you see here, this is two different terms. These are not multiplied, two different terms. And when you are doing with respect to y, x is a constant term. And when you are constant term integrating with respect to y, you have to multiply y. Remember, you have to multiply y. So we have multiplied y here. Plus integration of y is y square by 2. Next, we have to do with respect to integrate with respect to x term. There is an x term here. So x will be x square by 2, y will be as it is because it is multiplication. Plus, it is another term. Here we don't have x. So it is a constant term. So we have to multiply x to this. So that will be your answer. Try this, all of you. double integration x square plus y square dy dx. Yes, try this. It's a similar problem, so you will understand how to write the answer. Michael, Jonas, you can try this problem. Yeah, Michael, I want the answer from you. Michael or Michelle it is.
X cube y square by 3 plus x square y cube by 3.
X square?
X cube y square divided by 3 plus x square y cube by 3 plus c.
No, wait.
Y x cube by 3 plus y cube x by 3.
Yes, that is correct. See, Michelle, dy is there, integration first. So x square is a constant, right? If it is a constant, you have to multiply what? You have to multiply only y to this. You have to multiply only y. So let me write. X square is a constant and you are doing with respect to y. So multiply y plus y square is already, it is a variable. So it is y cube by 3 dx is equal to. Now when you are doing with respect to dx, here x is a term. So it is x cube by 3y plus y cube by 3 is a constant. So you have to multiply x. I hope all of you got the answer for this.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So I am not satisfied. So do this. Yeah, I want the answer for this. Integrate first with respect to dx, then with respect to dy.
Sai, that 2y cube or xy cube? The second
Can you
term.
repeat?
What is that the second term? Is it
2y
x?
cube, 2y cube, 2y cube.
Okay.
To the power 4 by y by 4y plus 2y power 4x by 4.
Y4 by 4 into x.
X plus c.
X
Okay.
4 by 4 y plus 2y 4 by 4 x plus c.
X4 by 4 plus 2y cube x dy. This is the first integration because we are doing with respect to dx means x to the power 4 by 4. 2y cube is a constant term, so we have to multiply x. Then again, when you do with respect to y, x4 by 4 is a constant term, so we have to multiply y plus 2 y to the power 4 by 4 into x plus c. Okay, you can simplify if you want. 2 to the 4. Okay. So now I can see that you have understood this problem. Yes?
Yes, sir.
Yes, sir.
Yes.
Sir.
Yes. Good.
Yes, sir.
Yes, sir.
Yeah. So I will clear this and we'll
Sir,
go for the next slide.
Sir,
Some more examples.
Sir, I am unclear about last slide.
What?
Last part. I think double integration of x cube. Plus
Last
2y.
one?
Yes.
Do you want me to explain? See, x cube is there. We are doing with respect to integration with respect to x. So x cube will be x to the power 4 by 4. 2 and y cube are constant when you are integrating with respect to x. So you have to multiply x to this. Done.
Sir,
So
how it possible? X cube is x to the power 4 by 4.
how x cube is x to the power 4 by 4?
Yes.
This is the formula.
Oh, yes. Okay.
This is the formula x to the power n plus 1 by n plus 1.
Okay.
Correct? And this is a constant, so we have to multiply x. Here I have shown you. If it is a constant, we have to multiply x. And when you are doing with respect to dy, this is a constant term, so you have to multiply y. and this is y cube will be y to the power 4 by 4 and remaining term as it is. Okay.
Okay.
Yes, I'll go for the next one. And even now, I want you to answer this. Integration, 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 x, y, z. See, don't worry. Just go one by one integrate. When you are integrating with respect to x, remaining, keep it as constant. When you are doing with respect to y, keep remaining constant. When you are doing with respect to z, keep remaining constant. Tell me the answer, what do you get? How it is? There is no limits here to get the answer as 1. First, with respect to dx, first, then second, then third.
X square, y square, z square by 8.
Correct answer. So see.
Sir, x square by 2 plus y square by 2 plus z square by 2 plus c.
No, there is no plus here, only into.
Okay, sir, into.
Yes. So see, you are doing first with respect to dx and one integration is gone. So 2 integrations are remaining and is x square by 2, keep yz as it is. And remaining is dy dz. Correct? One integration is gone. Then when you do one more, dy we have to do, another integration is gone. Integration x square by 2 as it is, y will be y square by 2 and z as it is. Okay. And when you are doing z, x square by 2 as it is, y square by 2 as it is, z will be z square by 2 plus c. Correct?
Yes, sir.
See, they give 3 integration or 2 integration, the procedure remains the same. You have to go one by one. And when you are doing with respect to one variable, other variables are constant. Check this one. Triple integration of 2 x square y cube z dx dy dz. What is the answer?
Sir?
What is the answer for this?
Hello, sir.
Hello, who is this?
Sir, Ruhul Amin.
Tell me.
So second integration we using plus or triple integrated we using into.
No, there is no plus. I did not use plus anywhere. I'm crossing this, not plus. Cross means this is gone. Here this is gone. Here this is gone. One integration is remaining.
Okay, sir.
There is no plus at all. It is a multiplication.
So x cube y 4 z square by 12.
X cube by 3, 4 by 4.
Y 4 by 4, by 2.
2 by 3, y 4 by 4,
First,
z square by 2.
First, with respect to x, so x cube by 3, you keep y cube z as it is. Then, with respect to y, so 2x cube by 3 as it is, y cube will be y 4 by 4, z as it is, dz. See, we kept this as it is and z as it is, only y cube we have written as y to the power 4 by 4. Then again, last with respect to z. So answer is 2x cube by 3, y to the power 4 by 4, z square by 2 plus c. See, you can simplify further, but here, if you get till here, the answer, that will be great. All of you got it right?
Yes.
Yes, sir.
So is reducing it necessary? Maybe we reduce it with 2.
What? I did not get you.
Reducing it because we have that 2 on top there and we have a 2 on z there. Can we just reduce it? Okay.
Yes, we can.
Okay.
We can simplify and you can write one more step. Okay. Now, the next example. Okay. Now this is very important. This is now slowly we are coming to our module. Slowly check this one. X is equal to 0 to 1. Y is equal to 0 to 2.
Sir,
Okay,
can you show? Sir, can you show the last last slide?
You have to wait for it. I can show you only at the end of the class. Here, that problem.
Okay.
You let me know. Okay, before erasing, I will ask if you want to write. Let me know. Okay, from next time. Yes. Try this one. I'm with the limit here. With the limit, we have to answer now. I will explain. Now see. Let me change this. Okay, guys. Let me write it as dy and dx. Okay. So see here. Always, whenever they will give the limit, here the first term and here it should be same. If it is dy, here should be y varies. If here it is dx, here it should be dx. This should match y variable and dy, dx and dx. Outside term and inside term. I hope you understood now. Dy means you have to integrate with respect to y first. You have to integrate with respect to y, keeping x to the power 0 to 1 as it is. So integration of x is equal to 0 to 1 as it is. Integration of keep x as it is. Integration of y is y square by 2. And what are the limits? 0 to 2. Understood the first step? I will repeat. We have to integrate with respect to y. So keep x as it is. Integration of y is y square by 2. And what are the limits of integration? 0 to 2. That's what I have written, 0 to 2. Now, before integrating with respect to x, simplify this. Simplify. What is the answer you get if you simplify this? Keep other term as it is. X is equal to 0 to 2. X. Simplify. In place of y, I need to substitute 2. So what I get if I substitute 2? 2 2s are 4 by 2 minus 0 dx. 2 to the 4, 4 by 2. If I substitute 0 here, it is 0. So it is 2 2s are 4. So I'll take that constant outside. X is equal to 0 to 2 x dx.
So 0 to 1.
Ah, sir. Sorry, 0 to 1 it is. I have written 2, I think, everywhere. So it is 0 to 1. Understood this step?
So can you repeat this?
Yes, I will. See, we have to integrate with respect to y. So y square by 2. And limits are 0 to 2. After integration, we have to substitute these limits inside. So in place of y, if I substitute 2, you get 2 square, that is 4 by 2. Minus, if I substitute in place of y 0, it is 0. 0 by anything is 0. Simplify, 2 to the 4. So 2 is remaining. That 2, I will take it outside the integral because it is a constant term. Remaining is what? X dx. Now we have to integrate x. What is integration of x?
X square by
x square by 2. And the limits are 0 to 1.
0.
Keep 2 as it is. Apply the limit. In place of x, 1 by 2. In place of x, 0, 0. What is the answer?
1.
1.
2 to get cancelled, 1 is the answer. Okay. So take your time and understand this problem because this is very important now. Take your time. And check what you will get the answer for this. Okay, what you will get the answer for this? I want all of you to check. This is x This is x. All of you, please solve this and tell me the answer. One by one, remember, integrate, simplify, integrate. Means you need to first integrate, then you need to simplify, then you have to go for integration. These are the steps you need to follow. What is the answer?
One, sir.
One, sir. Two, maybe. One.
Sir, 1.
1. So what you understood here?
One answer, sir.
One answer, sir.
One.
What you understood? What you understood? So we can see that if you change the order of the integration also, you are getting a same answer.
Same answer.
Yeah, means for a indefinite integral also, if you change the order, you are getting the same answer. And if there is a limits, a constant limits, I can say, because 0, 1, 2 are constant, right? If there is a constant limits, if you change the order of integration like dy dx or dx dy, you are getting a same answer. Correct? Let me solve for others. One who did not solve it. So integration of y is equal to 0 to 2, you have to keep it as it is. And you have to integrate with respect to x. So it is x square by 2. Limits are 0 to 1. And keep y as it is. Okay. Now, if you simplify this, integration of 0 to 2, that is y is equal to, and x square by 2. So it is 1 by 2 minus 0. Y dy. Okay, that 1 by 2 we can take it outside. Integration of y is equal to 0 to 2, y dy is equal to. Now integration of y is y square by 2. Limits are 0 to 2. So 1 by 2, and it is 4 by 2 minus 0. So 2 to the 4, 2 to get cancel. Answer is 1. It is same. So if the constant limits we have, if you integrate or change the order, means change the order, you will get the same answer if the constant limits. Okay. Yeah, that's it for today's class, guys. That's it for the today's class. I want you to practice the same problem whatever I have done today. Instead of solving a different problem, please go through the same problems again. Tomorrow we'll do some more problems. Then I will give you homework problems, workout problems. Okay.
Okay, sir.
But I request you to go through the same problem once again. One who did not understand or one who is studying this for the first time, you have to practice the same problem. Okay. Then only you can cope up. Yes, guys, I am sharing the videos. No need to worry about. I will share. Okay. Yes, PPT also I will share today's PPT. Yes. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Take care, be safe, and see you tomorrow.
I'll see you, sir.
You can leave the class, guys.